In this video, I'm going to show you an application of the enhanced criteria ranking process. The problem we're going to be looking at is that of multi-ingredient dietary supplements. These 5 ingredients that you're looking at here were of concern to the Department of Defense. Enlisted men and women consume these dietary supplements in various combinations and in various quantities. These 5 dietary supplements give rise to 27 possible combinations, including standalone consumption of one supplement at a time. The example I'm going to show you uses logical decision software. You can learn more about it here at its website. Let's go to our model first. Keep in mind we're going to have 27 different combinations of multiple ingredient dietary supplements. The Department of Defense concern is that people take these in large numbers and in multiple combinations. And the health effects of these multiple ingredient dietary supplements are not well known. There is a concern that these supplements could affect mission effectiveness for the enlisted men and women of the Department of Defense. So what we did was we decided that our goal was to identify the riskiest multiple ingredient dietary supplements. We knew we were going to have a lot of uncertainty and would be dealing largely with qualitative data. So then our next step was to go with the basic risk equation. Risk is a probability, or in this case, exposure, times a consequence. And then we would take the exposure and break it down into criteria, take the consequence and break it down into criteria. Let's begin with the consequence criteria because there are only 2 of them. We basically said that the consequence could be characterized by the severity of the consequence. Some could be fatal, some may only cause excess salivation. And they could also be characterized by the number of events that have been recorded in the literature and elsewhere. These 2 measures together would give us a means to rank the consequence of different multi-ingredient dietary supplements. When it got to exposure, we said the criteria we would use would be the population, the number of people using a particular combination, the frequency with which they used it, the duration of time over which they consumed this combination, the size of the dose, the availability of the combination, and the percent of this population up here that actually takes that dose. So we had 8 different criteria that were used. I am not allowed by the Department of Defense to use the actual data, and in fact the actual criteria changed a little bit. Soon enough we hope that this will all be available in a journal article, but until then I can only use this proof of concept model that we developed. So I'm going to take you now to a matrix. This matrix has dummied up data. What I would like you to see is that the rows are combinations of dietary supplements. The columns are qualitative or quantitative measurements for those 8 criteria that we just reviewed. Notice the percent of the population. If you scan down that column, you will see over 1% and up to 25%, less than 1%, and over 25%. So this is the way that we measured the percent of the population that was taking a particular combination of dietary supplements. Availability. If you scan down through this, you'll see some of these combinations are available as single ingredients. Others are ingredients in commercial products. If you take a look further down, you'll find in some cases a combination is not likely. And further down still, these are available in a single commercial product. So you can get this particular combination in a product that's for sale. The dose, large enough for adverse effect, not large enough for adverse effect. The duration, 1 or more years, irregular and episodic. and we also have regular but less than a year. The number of events recorded in the literature is quantitative. The frequency with which the dose is taken would be daily, weekly, less than weekly. The population of people who are prone to take these drugs was also quantitative. And then the severity. We had serious health effects, adverse health effects, no or very mild health effects. And so for each combination, we use the available evidence to rate each of our criteria. Now, where this software differs is it is a bit more sophisticated, and so it does allow us to do a good bit more work than what you see in the simple method. Once we have the criteria and the evidence for the criteria, the most critical measure then becomes the weights that we would assign to the criteria. So we're going to use a direct entry method here, and we're going to say assess, so that you can see over here on the right hand side we have some very precise weights for the different criteria. These were determined by the experts. Once again, these are just dummied up weights, so do not take them terribly seriously. But now what we have is an idea of what the most important criteria are, and it was the events measure and the severity measure. And then we had the other exposure measures making up most of the rest of the criteria, with frequency being the most important of the exposure measures. So we have weights for the criteria, we have the criteria themselves, we have evidence for the criteria, and now what we need to do is to generate some results. In the class, you learned how to combine high, medium, and low. This is a bit more sophisticated. We're going to use far more sophisticated techniques that we're not going to worry about right now. But multi-attribute utility theory is one of the options. The analytical hierarchy process is another. But we're just going to simply ask our software to identify the riskiest multi-ingredient dietary supplements. And voila, we get results here. This shows that caffeine and creatine is the most risky multi-ingredient dietary supplement. That wouldn't necessarily be because it alone causes the most severe or frequent problems, but it might be the number of people who are exposed to this particular combination of ingredients. What you'll see here from this software, and I don't want to spend a great deal of time on this, is this value of 1. This is a unitless utility value between 0 and 1, 1 being the highest risk, 0 being the lowest. And you can see it divides this risk measure up into 2 pieces. So we get an idea of how much consequence and how much exposure played a role in determining this. If we take a look here at this particular combination, we see consequence wasn't as important as exposure. In others, we see that consequence was more important than exposure in determining the overall criteria. This software has a good bit of sensitivity analysis that you can do as well. My purpose is not so much to show you how to use the software, but just to demonstrate that this technique, this enhanced criteria ranking technique, is in fact used for substantive risk ranking activities.